Hi, I'm Carl. In this video, we're going over questions 44 to 47 or Unit 16 of Section 3 of the Green Booklet. So this is a question about torque. I've copied out the diagram here and it's worth having a read over all the different values. And I filled in all the stuff that I think is relevant. Okay, so question 44 says, by equating appropriate forces about the pivot, it is found that the magnitude of T is equal to what? Okay, so we're told that this person is lying in a horizontal way, equally not moving. So around the pivot, we know that all the forces, let's say this is a spine, all the forces pulling it up are going to be equal to all the forces pulling it down. And that's a really important place to start. So from the perspective of the pivot, let's have a think about what forces are acting in either direction. So the resultant force R is not going to have an effect on this because it's acting at the pivot. So we're just going to be looking at the effect of T and W in this case. So pulling it up, we're going to have this force T, and it's going to be acting at T sine theta. And it's going to be acting at 0.7 L meters away. So that's the torque going up, and the torque going down is going to be the weight multiplied by the distance from the pivot, which of course is going to be 0.6 L. And we know these are going to be equal to each other, so that gives us an equation here. Let's sub in these values here. We're told that we can call sine theta alpha and we can call cos theta beta. So that means that we can say that T alpha is going to be equal to 0.7 L. And we can equate that to 0.6 W. Of course, multiplied by L on both sides. So let's get rid of the L on both sides, and that gives us T alpha multiplied by 0.7 equals weight multiplied by 0.6. The weight we know is going to be 420 newtons, and let's divide both sides by 0.7. So we can get this expression, T alpha is equal to this. Now, 7 times 6 is 42, so 7 times 60 is 420. So that's going to be 60 times 6. So T alpha is going to be equal to 360. So T is going to be 360 over alpha. So that gives us an answer in this case of C. If you look at 45 then, it says, by resolving vertical and horizontal components of appropriate forces, it is found that the magnitude of R is equal to what? Okay, so having a look at our diagram again, all the forces going up are going to be equal to all the forces going down. All the forces going right are going to be equal to all the forces going left. So I'm going to refer to the diagram that I have beside me here. So we have, let's resolve vertically first. Going up, we have R sine, and I'm going to call the angle gamma in this case. So this angle here, I'm going to call that gamma. It doesn't actually matter in the end, but it's just for now. We'll add that onto T sine theta, and we know that's going to be equal to all the forces going down, and going down we really just have 420 newtons for the weight. It's going vertically down, so we don't need to resolve any angles there. Again, sine theta is going to be alpha, so we can simplify this further and say that R sine gamma is going to be T alpha, and that's going to be equal to 420. So resolving horizontally, now we know all the forces going left are going to be equal to all the forces going right. So acting on the right, we have R cos gamma. Again, don't worry about the gamma, it's just to keep me right. It won't actually matter in the end, and I'll show you why. And we know that that's going to be, actually that's everything going in that direction, and that's going to be equal to everything going in the other direction, and we've only got T cos theta going in the other direction. Again, cos theta can be called beta, so we can say that R cos gamma is equal to T beta. Okay, so we've got a force, let's say going in this direction, another one going in this direction. We can resolve that and call that R. So the magnitude of r is going to be the length of this line. And so we really just need to use Pythagoras Theorem. So we know that vertically we've got a vertical distance or an expression for this, which is going to be r sine gamma equals 420 minus t alpha. And again, I'm just getting that from here. And we have horizontally then, we know r cos gamma is going to be equal to t beta. Okay, so now we've got everything in terms of r, we can start to resolve this. Because of Pythagoras' theorem, we can say that r squared is going to be equal to this side squared plus this side squared. So now we can get rid of our cos gammas and just use the right-hand sides of both these equations, and that will get us closer to an answer. So we know that if we square this length and add it to this length, that gets us a little bit closer. So let's square out these brackets and get t squared beta squared plus, and I think it'd be easier just to keep this in the brackets. And we just need to take the square root of both sides now. And we get something that looks a bit like this. And that, in this case, gives us answer A, instead of a negative, which would be answer B. This is definitely going to be a positive because of Pythagoras' theorem, so it's going to be A for this answer. So we've got two more questions now, 46 and 47, and they refer to some extra information, and that tells us that there's going to be a box that weighs 280. So let's redraw our diagram and add that in. So this is going to be for 46. So we've got our pivot here and our spine, and I'll just draw in the pivot again here. And it said that the box is acting at the end, or the free end of the lever, which is going to be down here, which is going to be a distance of L away. And that distance, of course, is going to be L. Okay, so what else do we know? We know that we've got our resultant force again. That's going to be acting at gamma, as we called it. We've got our weight, which is 420 newtons, and that is going to be 0.6 L across. And then we've got one more force, which is going to be this line here, which is T from the muscles. And that's going to be acting at 0.7 L across from the pivot. So that's all the information we need now to work out this particular question. And it says, in order for the man to maintain his spine in a horizontal position, so that's keeping it as it is, the magnitude of T must be what now? Okay, so at this point we just need to resolve vertically, and that gives us a value for T. So all the forces going down will be equal to all the forces going up. So all the forces going down, that's going to be our weight and the weight of the box now. And we're going to do this from the perspective of the pivot. So actually I'll redraw this. Say we've got our pivot here and we've got our line. All the forces acting in this way have to be equal to all the forces acting in this way. The ones acting down are going to be the weight and the torque produced by the box, and then T is going to be the one that's acting up. So what's acting up? We've got T sine theta again, and that's going to be a torque when we multiply it by 0.7 L. We can simplify this to T alpha 0.7 L. Great. And what about what's acting down? Well, we have our two forces with the torque produced by the weight, which can be 0.6 L multiplied by 420. And then we can add this onto the torque produced by the box, which is going to be 280 multiplied by L. So now we can set these equal to each other. And we can say that T alpha multiplied by 0.7 L is going to be equal to 0.6 L multiplied by 420 plus 280 L. Okay, so let's make sure that we get rid of all these L's. Now there's no reason to have them. And we can also get rid of this decimal here. So we could simplify this a little bit. and we can do T alpha equals 0.6 L 420 plus 280 over L. If we divide all of that by 0.7 L, that's pretty similar to what we had before. We know that this bit of it, this bit of it is going to be equal to 360. We did that in a previous question. So 280 divided by 0.7. Well, 4 sevens is 28, so that would be 400 then. Yeah, 400. So T alpha is going to be equal to 360 plus 400. So T is going to be equal to 760 over alpha. And that gives us an answer in this case of D. Okay, and then the final question is 47, which says that the box is going to be almost directly above the pivot. So it doesn't give us an exact distance from the pivot, which means you probably don't need to do any calculations in this. We just know that the weight acting down has to be equal to the weight acting up. And we're asked to find what the value of R would be in this case. So let's look at our diagram, the value of R. So we know that previously we needed to use an angle, and we don't know the angle at which this is acting now, but if it's acting directly above the pivot, then we can assume R is going to be vertical. And because we know all the vertical forces equal each other, everything acting up is going to be equal to everything acting down. R is acting up, and acting down we have our weight, which is going to be 420, and the weight of the box now, which we know is vertical, is going to be 280. So that gives us a value of R of 700 newtons. And in this case, that'll give us an answer of C. So that was Unit 16, or questions 44 to 47. I hope that helped.